Hi everyone, in this video we'll be demonstrating how to construct the parabola using the parabolic envelope method as a method that was discussed earlier. In previous videos we talked about the locus method and the rectangular method, so we'll be using the parabolic envelope method in this video. And then for us to make use of the parabolic envelope method, what we need to do, or all we need to know, is the height and the span of the parabola, just like we had in the rectangular method of constructing the parabola. So let's still make use of span 90 millimeter and height 80 millimeter. What you're expected to do using the parabolic envelope method is very simple. Draw a horizontal line like this, AB, equals to the span, that is 90, and draw a line perpendicular to it, BC, just like we have here. This is 90 degree, so they're perpendicular. AB, BC, the height BC equals 80. So line BC is equal to the height of the parabola, while line AB is equal to the span of the parabola. So what you're expected to do is to divide this part, line AB, into equal parts, and line BC into equal number of parts that were used for line AB. So if I'm dividing here into 10, I have to divide AB also into 10. If I'm dividing line BC into 10, I'm dividing line AB also into 10. So let's move on to dividing this line equally into 10 parts. Okay, so because of my space, I'm not going to get to 10. I would just stop at 8. I wanted us to use 10 so that we'll have enough points to join, but I think 8 will also do. So using the line division method, I'm just going to divide this part into 8 equal parts. That means I have to divide line BC into 8 equal parts also. So I have divided the vertical part and the horizontal line into 8 equal parts. So look at the numbering. We have it as 0, 1, 2, 3, 4, 5, 6, 7, 8. And then from this end to, we have it as 0, 8, 7, 6, 5, 4, 3, 2, 1. So 0, 1, 2, 3, 4, 5, 7, 8. So this point is sharing point 0 and point 8. So you can just make this so that make this protrude a bit so that it would indicate the point 8 for the vertical line, and then make this also come out a bit so that it indicates point 0 for the horizontal line. So what we need to do next is to join lines. Remember what we do in nursery school, where you join 1 to 1, 2 to 2, 3 to 3, 4 to 4, on and on like that. So we already have 0 joining to 0. So 0 at this point here, joining to 0 at this point. So we'll go straight to 1. 1, line 1, 2, line 1 on the vertical line. So we have line point 1 on the horizontal line to point 1 at the vertical line. So we move on to do the same thing at 2. So match 2 to 2. And 3 to 3. You do it all the way to 8. So you do it all the way to 8, just like we have here. 1 to 1, 2 to 2, and 8. And then we have 8 at this point is going to 8, so it's just going to be a straight line. And we have it there. So you should be having something like this. You can see that it already has the parabolic shape already. So what you need to do now is just to draw a curve that is tangential to these lines. Tangential to these lines, starting from this end and ending here. So this is the span, and then it is equal to AB. So just get your curve out. Just trace out lines tangential to it. So I have this. I'm supposed to use a pencil first to indicate that. So just tracing your points that are tangential. So you're not picking any point. You're just trying to outline this curve that is formed already by the lines that you used. So I have it at this point. So you can now use your pen to outline. So don't let your curve cross into any line. Let it just be on top of them as tangents, and you have it there. So for some lines it will just rest on them, and then for others it would pass, just like I have here at this point. So it's resting on this one, resting on this one, it's passing out about this. So this is what you are expected to produce using the envelope method of parabola. So you see, it's very simple and easy to get.